Okay, review. Find the value for C that creates a perfect square trinomial, then factor the trinomial. This is what that means, okay? C, you got to know this, it's per quantity. B divide quantity means a parentheses, B divided by 2 to the second power, okay? And then later you will be factoring this with the T table. So, A is 1, B is negative 10, okay? So, B is negative 10. So, first I divide negative 10 by 2, and that's negative 5 to the second power. Well, negative 5 to the second power is negative 5 times negative 5. Well, that is 25, okay? That's simple. Okay, so C is 25 now. That's your new C. Put that in there, okay? Alright, so you don't have to GCF. It's always going to be 1. 1 times 25 is 25, positive. So it's got to be a match of the signs. Now the nice thing about this, when you do that to find C, it's got to add to the B, which is still negative 10, just like before. When you use that formula, all you have to do to find the numbers is find the square root of 25. It's 5. Okay, so you put 5 on each side, and that adds to negative 10. I mean, 25 divided by 5 is 5, and there's your negative 10 right there. Okay. Now the A is 1x to the second. So if you want to put in your parentheses, you can. So negative 5, and then x, and then you just apply the 1's in front. Now those can't really be simplified. I mean, they would just stay the same because those are only in 1's row. So take the 1's off front. And since these are the exact same, we write it as x minus 5 to the second power. Okay. Okay, now you're converting the equation from standard form to vertex form. So, vertex form means I need to make it into an A, an H, and a K. So you're going to write y equals 3 times. Okay. And you are using the same tools that you used up there. C equals B divided by 2 to the second, and then the T table comes in later. Now, before you go down to your first parentheses, here's what you need to do. You need to make a parentheses around the x second and the x. Block that off from the minus 40, okay? 1. Now you make a new parentheses and the minus 40 is kicked out of the group. Now before you start writing this in, do you have a 1 right there in front of your x second? If you do, put a check mark. That means you don't need to put anything here and you don't need to divide, okay? So if we have 1x second, put a check mark. That's good. Means you can just drop the stuff down. Now, this is A, this is B. Now we come over here. B is negative 12. So the first thing I need to do is divide negative 12 by 2. That's negative 6 to the second power. So negative 6 to the second is negative 6 times negative 6, and that's 36. And that's your C value now, positive 36. Now, when you bring in that C, check the front right there, and there's nothing, okay? So, this 36, there's nothing in the front. There's nothing in front of the parentheses, so the number I brought in is 36, okay? 36. Actually circle it, okay? And there's no number out there to circle, so it's just 36. So I added a third, compare this side to this side. We brought in a positive 36, so we then need to bring in a positive 36 to this side. So it's on that side. Now I quickly need to minus 36, so the y becomes by itself again, and then the minus 36 goes under the negative 40, okay? So again, use the b divided by 2 to the second power. Negative 12 divided by 2 is negative 6 to the second. That's 36. There's no number in front to multiply the 36 by, so I just put plus 36 here. You're adding 36 to this side of the equals, you're adding it to this side, but then you're quickly minusing it so you can put it out with the outside number. Okay, ABC, now go to your T-table. 36, positive, it's a match, it has to add to negative 12. So negative, negative. Find the square root of the number 36 first, and that'll find your pairing, because it's the same pairing. It's 6 and 6. Add those, is it negative 12? It sure is. Okay, so that's what we need. Okay, go look up the A over here. It's 1x to the second power. Okay. So then xx, and you put the 1's in front. Okay, you can't simplify that then. So it's x minus 6. I rewrite that as x minus 6, x minus 6. And then negative 40 minus 36 is going to be negative 76. Now the last thing you do is you write that as an x minus 6 to the second power. Okay, with the minus 76 right there. Now, if you want to know if that's right, pick a random number for x, 5. You can pick any number you want and insert 5 into the original problem. Okay, negative 75, remember that. Let's see if I put 5 in here if it's negative 75. Looks like it. Okay, so that's right. Okay, next problem. Again, you need these two tools at all times when you need to do what's called completing the square. Okay, b divided by 2 to the second, and the t-table later. Okay, so y equals, y equals, y equals. Okay, first thing you need to do is just parenthesize that, and then drop the parentheses and kick out the plus 17. Now, remember what I told you. The x second has to have a 1 in front of it. It does not, so don't check that like you did on the last problem, okay? So what you do is you place this 5 out here. Then you divide this and this by 5, okay? Both of them divide, not 5x, because we want it to stay x second and x. So it's 1x to the second minus 6x, and then I leave this empty because this is my A, this is my B. Now it's time for me to find what my C is going to be, okay? Well, B is negative 6. Negative 6 divided by 2 is negative 3 to the second, so it's going to be negative 3 times negative 3, and that's 9. That's always going to be positive. Now, circle the C, and if there's an outside number, circle that. To find the number you need to add to the other side, you don't just add 9. You need to multiply 9 by 5. Here, I'll even write that. So the 9 I brought in, see on the last problem, I brought in a 36. There's nothing in front of the parentheses, so it's just plus 36 on the other side. But now, it's a 9 times 5, and that's 45. So the number I add to the other side is 45. Okay, 9 times 5. So you minus 45, and then you go minus it from 17 because you need the y to go back by itself. You have to add it over there so that it balances the equation because I'm adding a 45 to this side, but then I have to add it to the other side too. Okay. All right, t-table time. Okay, A, B, C, it's right there. 1 times 9. Positive, it's got to be a match on the signs. So it's got to add to negative 6. So all you have to do is square root 9 and it'll find what needs to add to negative 6. You can divide if you want like normal, but I'm just trying to save time because that's called completing the square. See, 3 and 3. Do those add to negative 6? Yes, they do. Okay, bam. By the way, if they'd have to add to positive 6, you just go in and switch them. That's all you'd have to do. Negative 3, and A is 1x second. It's always going to be 1x second when you're applying this method. So if you know that, you know it's just going to go XX, okay, because we always take the 1s off the front of the x's. So I'm guessing the 5 doesn't go away, it stays there. So I'm guessing I can just write that as x minus 3, x minus 3. Because remember, all I do is end up taking the 1s off anyway, and a is always going to be a 1, so then I go 17 minus 45. That's going to be negative 28. So you have 5, and then x minus 3 to the second power minus 28. Okay, find the value of k that makes a perfect square trinomial. First off, I don't like the letter k. Put it as b, because that's what we're used to having there. Now we found c, we have to find b. Okay. All you do is take the square root of the c and then multiply it by 2 after you take the square root of it. Okay? Or actually, hold on a second, that's wrong. Don't write that. Okay? It's the square root of a times c, then times by 2. Okay? Okay, so a and c, so it's 1 times 9. Okay? We know that's 9. The square root of 9 times 2. Square root of 9 is 3 times 2 equals 6. So b equals 6. Instead of k, just put b. Okay. Just the square root of the AC product. AC product's 9. 1 times 9. Square root of 9 is 3. 3 times 2. You always times it by 2 then. Because the square root of 9 is 3. That'd be 3 and 3 to make 6 in the middle. Okay. So now it's time for the I stuff. Find the value for I. We have I to the 8th power. Remember, split that into I to the 2nd powers. There's I to the 2nd. What's 2 plus 2 make? 4. Tell me when I'm at 8. 6, 8. All of these are replaced with what they're always replaced with, negative 1. Now just multiply it on a calculator if you have to. It's going to be positive 1. It's not always positive 1, but because there's an even number of negative factors now, it's going to be positive. Okay, simplify. Complex numbers, C1, C2. You got a plus sign, that's easy. It's just the constant plus the I. So 4 plus 2 is 6. Negative 5 plus 10 is 5. Now you're multiplying, simplifying by multiplying, okay? So it's a C1, C2, multiplication. So I take 8 times 8, distribute, and 8 times negative 1i. Then negative 6i times 8, and negative 6i times negative 1i. So this is 64, this is negative 8i, this would be negative 48 with I, and this would be positive 6, but it would be with I to the 2nd. So take your I to the 2nd out, because that is always replaced with negative 1. 6 times negative 1 is negative 6. Now these two are combined, and so are these two. So the constant 64 plus negative 6 is 58. And on the i's, negative 8 plus negative 48 is negative 56. Okay, next problem. Okay, this is C1. We got to get a C2. Well, you get rid of the 2nd power, you make a multiplication, and C1 and C2 have the same things inside. 7 plus 5i. You just duplicate the two terms. No, you don't switch it. You don't switch it. It's not the conjugate method. A 2nd power means everything's the exact identical. Okay, then you do the FOIL method. So, 7 times 7, 7 times 5i. 5i times 7, 5i times 5i. So that's 49. That's 35 with I. This is 35 with I. This is 25 with I to the 2nd power. Get the I to the 2nd power out of there and put negative 1 in. So it's negative 25. So we combine those. That's 24. And these do not add to 0. They add to 70i. Okay, now we're finding the quotients. Remember how you need to find quotients, okay? You're going to need to write a new fraction, but you need to parenthesize the top and the bottom, and you need to times by another fraction that has the same, this and this have to match, okay? Now the whole point of doing it is to get the I out of the bottom, okay? Alright, so this is one term down here, so that's good. I can just put I, and then I put an I up there. Whatever I put here, decide to put in that parentheses, I have to carry that up to the top. Now, you need to find your new top and your new bottom. Okay, put ones in front of the i's and start multiplying. 8 times 1i, and then 7i times 1i. So that's 8i, and this would be 7i to the second power. So I to the second power is replaced with the negative 1 like always. Oops, put it there. And then 7 times negative 1 is negative 7. So we put negative 7 plus 8i in the numerator. Now denominator, you're just taking 2i times 1i. Just one product you have to find. So it's 2i to the second. Negative 1, 2 times negative 1 is negative 2. So you put negative 2 down. Now you're going to divide. Okay. So negative 7 divided by negative 2 is 3.5. And then 8 divided by negative 2 is negative 4. But you're still multiplied by I with the negative 4. Okay. See, I don't put I here because 7's not multiplied by I, but the 8 is. So whatever quotient I get has to have I. Okay, same thing on the next one. You need to make a new fraction where we can actually divide. We get that I crap out of there. Now, this is two terms. Two terms, you apply the conjugate method of multiplication, meaning 9 stays the same, but the positive 2i switches to a negative 2i, and whatever is in there needs to be copied and duplicated on the top, so that we're multiplying by the top by this and the bottom by this. They have to be multiplied by the same thing. Okay, top, bottom. Okay, so first thing, I distribute 3 to 9 and 3 to negative 2i. And then negative 4i to 9 and negative 4i to negative 2i. You can draw the rainbows underneath if you want. Okay, so this is 27. This is negative 6i. This is negative 36i, and this is 8i to the second, so you replace I to the second with negative 1. 8 times negative 1 is negative 8. (27) plus negative 8 is 19. Then the I is negative 6 plus negative 36 is negative 42. So that is what is going on top. Now the bottom, you take this, do the same crap. 9 times 9, 9 times negative 2i. That's done. Now you take 2i times 9, 2i times negative 2i. So this is equal to 81. This is negative 18i. This is positive 18i, so we cancel those. Okay. Negative 4i to the second, so the I to the second replaces with negative 1. Negative 4 times negative 1 then is positive 4. Now these combine. 81 plus 4 is 85. Now you do the division. Okay, so I'll do 19 divided by 85. You get a decimal, second PRB at 19/85. Okay. Then I take negative 42. Remember, that's multiplied by I divided by 85. Second PRB, because I don't want that. We'll did that wrong. Negative 42/85, but you still need the I connected on that one. Okay, and that's your quotient. Okay, now the equations. Negative 2x to the third minus 3 equals 37. So, well, I have x second only. Okay, well, that's linear properties. You should know that by now. There's two answers. So you get rid of the minus 3 with plus 3. That would take you to 40. You divide by negative 2, and that's negative 20. You take out the second power at the square. Oh, we have negative under the square root. Well, it's still positive negative. We just need to make that an I. Now, I square root 20. Every time with an I, you need to square root it. Oh, it's irrational. Put divided by, and you make your two square roots with the I in between. So you start dividing, okay, off the board. 20 divided by 16 decimal. 20 divided by again 9. No. 4. Yep. 4 and 5. 4, 5. Well, the square root of 4 is 2. So it'd be 2I square root of 5, and that's the answer. All right, next problem. 3x to the second power minus 5x plus 8 equals 0. Okay, so you have x second and you have x. So now you're not using the linear properties, you are using your factoring properties. Okay, check off your 0, it's there. So there's 3 terms. So GCF, and then my buddy the t-table. No x, no negative, 3, 5, and 8's 1, okay. 3 times 8's 24, it's positive, so it's a match, okay. So you can put double negative or double positive, doesn't really matter, it's not going to matter anyway because you're not going to find it. 124, that adds to negative 25, that's wide. 24 divided by 2 is 12, it's negative 14. 24 divided by 3 is 8, that's not it, that's negative 11. Okay, add them, it's negative 11. Think of a number line, okay? If you're at negative 3 and you add a negative to it, you're moving backwards, it's negative 11. 28 divided by 4 is 6, that's negative 10. And then 24 doesn't even divide by 5, and then I'm just at 6, which is on the other side of the table, so that's a QF. On this test, the problem will be QF. Okay, if you want to forego that, fine. Opposite of B, plus or minus the square root, B squared minus 4AC, B squared minus 4AC over 2A, over 2A. Okay, so opposite of B is going to be positive 5, A on the bottom is going to be 3, and then B, negative 5, A is 3, C is 8, okay? So you have 5 in front, 2 times 3 is 6, you set it up, okay? Negative 71. What did I tell? On quadratic formula, we have dropped decimals down there before, but not with the I, you ain't. If you do the I, you're doing exactly what you're doing here. You're trying to square root it. Oh, it's irrational. IRR that. Put the division, and you have to do this when there's an I, even on the quadratic formula. So then you go through the list on the board. The only thing it divides by is 1. So put 1 with 71 with the I in between, and the square root of 1 becomes 1. So down here I'm just putting 1I square root 71. Then 5, 1, and 6. The 71's not is staying. That's frozen. 5, 1, and 6, the GCF's 1, so you wouldn't be able to divide them down by a common factor, so that would be the answer. 5 plus 1i square root 71 over 6. 5 minus 1i square root 71 over 6.